Okay, so this video is meant for geometry. This is your second half of Chapter 3 review for your test, covering sections 3.5 through 3.8. Got a couple problems here to work on for this test. So here we go. We have a picture of three triangles, actually. Two triangles inside one big triangle, and we have to find x, y, and z. Okay? So you can do it any way you want to, right? Find them in any order. I'm going to find x first. X is part of this triangle on the left, as I outline it. I know that this is 30 and 80. These are two of the three angles, and x is the third. I can find x using the triangle angle sum theorem, which says that the measures of the three angles, x plus 80 plus 30, should equal 180. We'll combine 80 and 30 to make 110. And then we'll subtract 110 from both sides to get x equal to 70. Now that we have x, look at where y is. Y is a linear pair with x. Alright, so see how we have a linear pair. Linear pair postulate says that the two angles are supplementary. X plus y should be 180. But I know x. X is 70. Substitute 70 plus y is 180. And subtract 70 from both sides. Y is 110. You could have also used the triangle exterior angle theorem for y, because y is an exterior angle to the blue triangle, so y should equal the sum of the two remote interior, 30 and 80. That would be 110. And now we go to z, and for z I'm going to focus on the triangle on the right. I'll do it in purple. Again, in this triangle, we know that the three angles should add up to 180 by the triangle angle sum theorem. Those three angles are z plus y plus 40. We know y is 110. Plug it in. Equals 180. I apologize, getting ahead of myself. Plug in 110 for y. Z plus 110 plus 40 is 180. Combine the 110 and 40. Z plus 150 is 180. And subtract 150 from both sides. And z is 30. And again, you can use the big triangle to check. 80. And this right here, this angle right here would be, I'll do it in purple, would be 70. 80 and 70 is 150, and z is 30, and 30 is 180. So it checks out. We did the problem right. 2. Use the given information to find unknown angle measures in the triangle. The measure of one angle is 108. The measure of the other two angles is in a ratio of 1 to 5. So I could also write this as one angle is 5 times the other. I'm going to put that here. One angle is 5 times the other. Because if it's in a ratio of 1 to 5, one angle is it, and then the other one is 5 times that measure. Alright. So how do we do this problem? Well, I'm going to draw a triangle, and one of these angles is 108 degrees. Okay. So we need to find the measure of the other two. Well, they're in a ratio of 1 to 5, or 1 is 5 times the other. So if we let one be x, right? Look at this one x. Let that be x. Then the other one has to be 5x, right? 5 times it. And here are our angle measures. 1x and 5x. The 108 plus the 1x plus 5x have to add up to 180. The triangle angle sum theorem. X plus 5x plus 108 has to be 180. Combine your x's. We have 6x plus 108 equals 180. Subtract 108 from both sides. 6x equals 72, and divide by 6. And x is 12. So if x is 12, that means that angle is 12 degrees. And this one, 5 times 12 is 60 degrees. 108 plus 12 is 120, plus 60 is 180. So we have the two angle measures. So be aware of this. One angle is 5 times the other. X and 5x. Or the same thing with the ratio. Multiply both sides of the ratio by a variable and use those as the angle measures. 3 is a construction. We're going to construct the line through J parallel to AB. And what I'm going to do is redraw it down here. So here is my line, and here's my point J. I'm going to put that point right where they do. I'm going to put it over here, actually. Okay, so again, my tools, I don't have them, so just bear with me with these straight lines. But we'll do the steps. Here we go. First step. We need to draw a line through J and through this line. And this line has to be angled a little bit. So we're going to do our best. And make sure you extend this line up. Okay, and we'll call this point something. Let's call this point P. Next, we need to create an arc in angle P. So to do that, we're going to take our compass, open it up some length. So say I open it up to this length, and we're going to create an arc. Just like that. And I need these two intersection points. That's important. And I'll do the same thing up here. So I'll take it on J, go about the same distance, and make an arc. Just like that. Notice I brought the arc down low enough because the parallel line is going to go through that arc. And now what I do is I need to open up the compass to as wide as these 2 points. There's my compass. It's that wide. I'm going to put the point up here on this point, and I'm going to make an intersection right there. So the point is up here, and I make that intersection. That is the second point I need, that intersection of those arcs, to draw my parallel line through, and here it comes. There. And that's the line that makes these two parallel, or that is the parallel line through J. So practice those videos. Watch those videos. Practice the steps. You can just hand draw them, okay, to practice. And then make sure you can use the tools when you come in. 4, here we go. Write an equation of the line perpendicular to the given line that contains P. Alright, here we go. This word perpendicular should mean something to you. Perpendicular means opposite, reciprocal, slope. So they give you a line, and in this line, the slope is 1/2. You must use the opposite reciprocal slope to 1/2. So the opposite reciprocal of 1/2 is -2. -2/1, but just use 2. So the point we'll use is this point, 4, 0, and the slope we'll use is -2 in point slope form. Y minus y1 equals mx minus x1. Y minus 0 equals m -2 x minus 4. This y minus 0 is just y. If this were another number, we would have to add or subtract it later, but it's just not, it's 0, so it goes away. And now we distribute -2. -2x plus 8. And again, if there was something with the y, we would now add or subtract it, but there's nothing with the y, it was just a 0. So there's your equation. Notice that your two lines have opposite reciprocal slopes. Okay, last one here. Use slopes to determine whether the opposite sides of a quadrilateral ABCD are parallel. Okay. When they call this quadrilateral ABCD, that means that if you have a four-sided figure, it goes in order. A, B, C, D. So this is how you determine what sides are opposite. AB is opposite of CD. AD is opposite of BC. So we need to find the slopes of these 4 lines. So let's start with the slope of AB. Now over here I'll put the slope formula. Slope is y2 minus y1 over x2 minus x1. This word parallel means equal slopes. So we're looking for opposite sides that have equal slopes. Okay, slope of AB. Y2, let's use 4. That's the y of B, minus y1, which is 2, the y of A, over 3, the x of B, minus 0, the x of A. That is 2/3. Okay, let's see if CD has a similar slope. Should have the same slope, hopefully. CD, use D, y, 5, minus 7, -1, minus 2. That is -2 minus 3. Make sure you simplify. A negative over negative is a positive. Same slopes means AB is parallel to CD. Okay, there's the first set. Now let's do the other two. That would be the slope of AD use D's coordinates 5 minus A's coordinates 2. There's the y's over negative 1 minus 0. That's 3 over negative 1. Divide them, right? Dividing by 1 keeps it the same, but it's a negative and a positive. That's a negative 3. So let's see if BC is the same. Use C's coordinates 7 minus B's 4 over 2 minus 3. That is 3 over negative 1 simplifies to negative 3. Hey, they're the same. Slopes are the same. Lines are parallel. So in this quadrilateral, both pairs of opposite sides were parallel. Okay, so that's the video. Those are 5 good examples. Make sure you are practicing Interact Math. Look at the in-class problems. Make sure your notes and note cards are done for your test on Thursday. All right. Good luck. Happy studying.